So we continue with question with the part where we need to find out about the change in the momentum of the motorcycle, which is C. If we approximate the value of the velocity of the motorcycle after the collision, we come up, so I did put this in a calculator, come up approximately 6.03. So we're going to roughly estimate about 6. Now, the question here is the velocity, the change in momentum, Now, you notice here in the formula, the momentum is mass times the velocity. So if we talk about the change in momentum, we need to talk about the change in something. You can't talk about change in mass. The mass doesn't change of any object. The mass stays the same, so it has to change the speed, right? The velocity. So conclusion, if we talk about the change in momentum, we talk about the mass times the change of the velocity. Now, velocity is changing from what to what? Well, obviously, if think about after the collision, we still have a movement and the velocity of the whole system moves at 6.03, then we can consider the initial velocity from, and I'm going to underline, since we're talking about the motorcycle, I am going to take the initial velocity of the motorcycle as 43 meters per second, and then I have to subtract that, subtract 6, and I'm going to roughly estimate to 6. So the change of the momentum, let me just write it here. The change of momentum of the motorcycle, I'm going to put M, which is the motorcycle, is equal to the mass of the motorcycle. And I'm going to just plug it in. That would be 430. Okay. Times parenthesis, because we talk about change is a difference. Initial velocity was 43. And you know what? Let's just be more precise. It's 6.03. Subtract 6.03. All right. So we're going to grab the calculator. And that would come up as 430 times parenthesis 43, subtract 6.03, and you would come up about 15.9. I would say 15.9. And of course, all the units come exactly the same as for the momentum, which would be the kilogram times the meter per second. Now, the same way you're going to have to do the momentum for the car, the change in momentum for the car, except for the car, of course, what is going to be different is the initial velocity of the car, and the mass of the car will be different, right? So it's a simple calculation. The final velocity will stay the same, 6.03, because this is the velocity of the system after collision. So now that would answer the question for D. What is the velocity of the car after the collision? Well, that would be exactly as the velocity of the motorcycle after the collision. And guess what? What is the velocity of the system? Same as the car and the motorcycle, because both of them have the same velocity. So this would answer these questions. We have one more where if both vehicles come locked together, what is momentum of the system? The momentum of the system would be an addition, would be the sum of the momentum of the car and the momentum of the motorcycle. So technically, I'm going to say is the momentum of the car plus the momentum of the motorcycle. And we just talked about that in the previous question. So the momentum of the car, I'm going to circle, is right there. And then, of course, the momentum of the motorcycle, you multiply 430 with 43. And then you add them up. And that would be the momentum of the system.